Namaskar and welcome back to another lecture in our course on Infrastructure Asset Management, the course being offered under the MOOCs scheme of the Government of India. We are in week 2 of this course and we are talking about stakeholders and life cycle of infrastructure through examples. In this lecture today, where we are taking up illustrative examples, we will talk about a situation of contaminated water supply in a neighborhood. This is the normal warning which I give for each lecture. The material being circulated here or shown here is strictly for academic and instructional purpose, and you are not expected to use it for any other purpose. And what you see on the screen is like the blackboard, and please make it a habit to make notes as usual in the old fashioned way, using what is projected and what is stated. To recap what we have done in module 1, we have talked about the overall administration of the course and the technical content, including the characteristics of the infrastructure projects, massive initial investment, long service life, diverse stakeholders, and the fact that projects could be under diverse environments and subject to damage over time due to this exposure under the action of different mechanisms. Deterioration and performance are related but not the same, and independent parameters can at times be used to monitor their variation over time. Infrastructure management, the processes involved, that is inspections and so on, and the interventions like repair, rehabilitation and so on. Then we talked about simple concepts in economics and economic decision making, including the challenges in applying them in infrastructure management. Moving forward, this is the graph, or this is a schematic representation of what we have often talked about in module 1. We have talked about performance changing over a period of time. We have talked about critical performance levels and that defining the service life. Then we talked about the deterioration increasing with time, performance going down with time and so on. Now, in this module, we are learning about the different stakeholders and the life cycle of infrastructure projects through illustrative examples. Now, in the first example that we took up in the second lecture of this week, we discussed how the complex interdependencies and possible lack of foresight and lack of funds could lead to an unfortunate situation where a multi-story residential building ultimately collapsed, even though all stakeholders involved more or less knew that the deterioration levels are fairly severe. Over a period of time after the initial signs of deterioration were noticed, that there was a lot of red tape and indecision which resulted in progressive deterioration, and finally when everybody was on board, unfortunately the building collapsed. So, moving on, I would like to again emphasize a disclaimer that illustrative examples that we are taking in this module are adapted from different real events and presented in the framework of the infrastructure management that we are talking about in this course. We will see certain obvious lapses, deviations from established SOPs for various reasons, including experience, lack of resources, incomplete understanding, lack of understanding of one's own position with respect to the position of other stakeholders and all that. The discussion here is not to point out fingers at each other or one stakeholder or another, but to try to learn and develop a more robust system of infrastructure management with all stakeholders being taken on board in the process and they really working as a team and as partners in the whole exercise of management. Now, in our discussion today, we will talk about a contaminated water supply in a neighborhood, and before we go there, let us try to see what we are talking about. We expect as users that potable water will be available 24/7 when we just turn on the tap. Now, it is not so easy. We hardly pause to think of the effort and the infrastructure that goes at the back end to make this happen. We have to talk about the source of water. Where is the water coming from? It could be a river, it could be underground, it could be a lake, and so on and so forth. The water that we get from that source need not be absolutely fit for drinking as it is. Sometimes it is, sometimes it is not. it requires a certain amount of treatment at times. For that, we need to test the water that we are going to use and try to understand what kind of treatment is required to make it fit for human consumption. There are different standards which we talk about, which define the parameters for human consumption, for other purposes, and I am leaving that part of it to you as an exercise to find out. Now, in order to do that, to get the water from the source to my house or your house or an apartment or wherever it is, we need a pipe network. And this pipe network we can divide into two parts. One is from the source to the treatment plant, and the other one is from the treatment plant to individual houses. There are different agencies that are involved. Different states in India, different countries in the world have different agencies involved in the process of fresh water supply to residents. But at the end of it, water supply is not a private issue in the sense that it is not the same thing as individuals making bore wells, having tube wells in their property and then trying to use that water. The government agencies, municipal authorities, water management utilities are somewhere or the other involved in urban systems. And it is also important to note that the pipe network that we are talking about could be very old, and we may have only very limited information available on the type of material which was used or the condition of the pipe as it stands today, especially in older cities where pipes could have been laid 50 or 60 years ago. So, it is very difficult to have a full map, and efforts are going on in different parts of the world, different cities in the world to map these lines. But at the end of it, that information could be missing. Now, I cannot resist sharing with you some of the questions that I would like to leave for you to think about before we talk of the illustrative example or the story that we are going to build today. What could be the potential sources of water? Try to find out in your own neighborhood what is the source of water. In certain countries where fresh water is in scarce supply, there are plants that desalinate seawater. Try to study some of those features from different parts of the world. What are the quality parameters for potable water? That is what we alluded to, that for example in India, there will be standards which define that okay, for human consumption this is what it is, for agricultural consumption this is what it is, for industrial consumption this is what it is. So, at times we see in public places where it is written that this water is not fit for drinking. At other places it is written that it is drinking water. Certain countries in the world pride themselves that all water on public taps is fit for drinking. In certain countries that is not really true. So, what I am asking you to do is to find out the quality parameters. As you are emphasizing in module 1 also, there have to be quantifiable parameters to help us understand the quality of water. Only then we can try to have treatments or technologies which will improve the quality of water. So, here we are talking about quality parameters for potable water. Try to compare these parameters across the globe and try to see if they are different in different countries. Moving on, what is the physical infrastructure required for the water supply? The pipelines from the source to the treatment plant, the components of the treatment plant itself, what are the processes involved, then what is the design of pipe network from the treatment plant to the individual houses. Is it coming straight or is it getting routed through overhead tanks and so on? And lastly, what is the nature of agencies engaged in water supply? I already said that different countries, different provinces will have different models for doing the management of this infrastructure. Basically, the idea is that the city or the water management utility, whatever it is, generally has a main line, and from there is a line which is taken to individual houses. So, up to this point the water supply is governed by the city or the utility, and this part is controlled and managed by individual owners. So, keeping that in mind, try to see who are the agencies which are involved with this part. That is, the water coming in here, it may be coming from a treatment plant, and there is the source at the back of it. So, what kind of infrastructure do we have here? What kind of an infrastructure do we have here to ensure that what we need here is delivered 24/7. In case it is not possible 24/7, then there are different schedules that the municipalities will come out with, that okay, water supply will be restricted or not restricted, and so on and so forth. Now, with this background, let us try to summarize the gist of the story that I am going to tell you. The water supply management in a neighborhood switched sources. The water was being taken from a source S1, which was changed to S2 to save money. Now, where does the money component come? The decision was guided by financial trouble at the utility or the authorities who were trying to manage the water supply system, and the owners of S1 wanted to add a cost of water collection. So, after all, the source here, which is S1, is also managed by somebody. So, for example, if you are talking of a river system, the river management has its own authorities, regulators, bodies, and so on. So, those people had been giving water free of cost, so that access to water was free. But at some point in time, they said no, there will be a cost associated with the water that is drawn from that source. Now, the utility did not want to make that payment and switched to S2, which was somehow free. Now, no change was made in the water treatment strategy, and it was assumed that no such change is required for a new source. Now, what is shown here is an aging infrastructure of pipes. The pipe condition is the same at this point in time. It was laid a certain period of time ago, maybe 50 years, 60 years, whatever it was, and we were getting water from this pipeline, and there was no issue so long as the water was being taken from source S1. Now, what happened is that when water was drawn from S2, it caused more corrosion in the old pipes and caused the lead in these pipes to leach into the water supply. So, these pipes, they had severe leaching which was observed, and this leaching caused lead to be released into the water. So, what we got here was contaminated water. Moving on, there was a confirmation that lead contamination is there in the water supply, and this affected the neighborhood and exposed thousands of residents to toxic water. The matter was more serious for children, where it is known this exposure to water containing lead could have effects on things like brain development and also long-term health implications. This study or this story that I am telling you is presented with the idea to bring forth serious flaws in public health governance and the infrastructure management of the water supply. What was the timeline involved? Now, if we look at the timeline, which obviously is a fictitious timeline, let us say in 1960, it could have been any other year that I could have given, there was a switch in the source of water supply from S1 to S2. There were initial complaints from residents immediately, especially relating to odor and color, and soon their numbers increased dramatically. Now, once these complaints started coming to the management authorities or the water utility, there was initial denial. That is, officials insisted that there is no problem and the water was safe, but the complaints persistently increased, and over the next almost a year, there were reports of skin rashes and hair loss also started to be reported. An independent private study was carried out at that point in time, let us say by a doctor, and the data revealed that there was a significant increase in the blood lead levels among children after the switch to S2. which reinforced the hypothesis that water being supplied was dangerously contaminated with lead. Now, what this example tells us, or what this illustration tells us, is that we really need a lot of data to be able to make certain assertions, and that data has to be collected and analyzed. So, for example, what is being stated here is that there is a doctor who carried out some study, collected data, and found that there is a significant increase in the blood lead levels in children after the switch to S2. Now, this can be conclusively established only if there is at least some data in the S1 regime. As far as the time is concerned, here was the switch that happened, which is given to be 1960 here, that we were using water from S1 and then we started using water from S2. Now, we have to have data from this regime and we have to have data from this regime to be able to conclusively say that, well, there is a statistically significant increase in the lead levels. Now, that statistically significant difference is again a scientific matter. So, what we are trying to show throughout this module or throughout this course, as a matter of fact, is the fact that there is a lot of science and engineering that's at the back end of infrastructure management. So, with this kind of data, it became difficult to deny that there was some problem with the water supply. And finally, there was an admission, too late perhaps, late in 1962, a hypothetical figure again, the authorities admitted the presence of lead in the water and emergency steps were initiated. And by that time, unfortunately, a lot of damage had been already done. Now, why did it happen? There are different ways of looking at it. One was the cost-cutting decision of switching in the supply source. Then there was a critical lack of proper treatment, inadequate testing of the water from the new source and its implications. Aging infrastructure, the unmapped pipe infrastructure and its health. If it had been known, things could have been done in an experimental manner to begin with, carefully monitor it and then switch completely to S2 or somehow stick with S1 no matter what the consequences. The initial denial and lack of action. Now, this caused loss in time. The kind of timeline that I gave you, 1960 was when the initial switch was made, 1961 some complaints started coming in, and only in late 62 there was the admission that yes, there is a problem. So, this initial denial and lack of action caused the problem to possibly exacerbate, become a lot more serious and caused a lot more health issues among the residents. Of course, post disaster, there were the usual steps. As far as public health is concerned, steps were taken to ensure that people who had suffered lead exposure were appropriately and properly treated. Provisions were made for their long-term treatment if required. Infrastructure steps were also taken to ensure that all the pipes are either monitored or changed. There was trust erosion, and that's something which is very difficult to restore. The trust of the people in the water supply system was deeply eroded, and that's something which will take time to restore. There were lawsuits, the different stakeholders suing each other, the users or the residents suing the municipal authorities or the water management authorities and so on. There was administrative action against people who were identified as culpable, who took decisions, but all that, the source was restored, does not reduce the seriousness of the disaster, and of course, the source restoration to S1, water was not going to be taken from S2 and the water supply went back to S1. Let's not bother about whether the cost that S1 had imposed was to be paid or not to be paid and so on. Now, the lessons learned as far as this illustrative example is concerned, we can talk in terms of the government accountability, we can talk in terms of investment in infrastructure, we can talk in terms of environmental justice, that is, all the people have a right to have safe drinking water. Swift crisis management, that is, even at the first instance when there are complaints, appropriate and proper action needs to be initiated, especially in cases like water supply, which is a critical lifeline, to ensure that the residents are properly guarded, and proper oversight, that is supervision by the federal authorities, the state authorities, and possibly a watchdog body which also has representatives from the users. Now, before we close the discussion today, I would also like to point out that as far as the cost of the management is concerned, we can always look at this as made up of two parts. One is the cost of prevention, and the other is the cost of failure. Now, if we invest money in ensuring that the infrastructure, the water supply is safe, all the data is collected, the monitoring is done, there is a certain cost which is incurred. That cost has to be compared to what the cost of failure is. For example, in this case, which I discussed just now with you as a hypothetical situation, the cost of failure is simply enormous. It's not only the infrastructure or the health, it is the loss of faith, the loss of trust. Now, those are costs which cannot be compared, which cannot be monetized, and therefore, in our infrastructure management, we should always focus on steps to ensure that the infrastructure remains sound and integrity is maintained. Prevention is the best way, only way to ensure that the infrastructure will continue to serve us. With this, we come to an end of our discussion today. And before we close, I'll share with you a list of references or material for further reading, which will help you understand the subject matter covered today and being covered in this entire course. And I express my thanks to all my teachers, colleagues, and students who have contributed to my understanding of infrastructure. Thank you, and I look forward to seeing you again in another lecture.